A number system is a systematic way of representing numbers. We use number systems to do mathematical calculations like counting or computing something or measuring any task. We also use our fingers to do some simple mathematical calculations. So, as you know, numbers are composed of digits. Each digit in a number has its own value. So, that value is determined by the digit, position in the number, and the base of the number system. So using the numbers, we can also perform arithmetical calculations such as addition, subtraction, multiplication, and division. In general, there are different classification of numbers. Some of the classifications are natural numbers, counting numbers, prime numbers, whole numbers, rational and irrational numbers, etc. So numbers play an important role in computers, digital electronics, etc. A computer system processes the information and perform the calculations with the binary numbers. Also, in digital electronics, the number system is used for representing the information. The logic circuits perform their operation considering the binary numbers. So there are different ways to represent numbers. The most popular types of number systems are decimal number systems, binary number systems, octal number system, and hexadecimal number system. These number systems are called as positional number systems because these number systems have an ordered set of digits, right? If you consider the decimal number system, it has 0 to 9. These are the digits that are included in the decimal number system which we use in our daily life. A binary number system, it consists of only zeros and ones. That is why it's called as a binary number system. An octal number system consists of 8 digits starting from 0 to 7. That's why it is called as an octal number system. Whereas hexadecimal number system, it has 16 characters, 0 to 9 numerical characters followed by A to F, which are alphabetic characters. So it has totally 16 characters and hence called as hexadecimal number system. First, let us look at the decimal number system. The decimal number system consists of 10 numbers 0 to 9. 0 to 9, total 10 numbers. So the example of decimal numbers are 23, 420, 8503, any numbers, right, which we use regularly. Since it has 10 digits, the base of the decimal number system is 10. And the weight of each digit in a decimal number is expressed as a power of 10. Since it has 10 numbers, the weight is expressed as the power of 10. Let us consider an example of a decimal number 2647. So in this number, each digit has its own weight. Normally we used to say the digit 7 is in units position. What it means, the weight of the digit 7 is 10 power 0. This 10 power 0 denotes, in this 10 power 0, 10 denotes the number system. Here it is a decimal number system, hence it is written as 10. And this 0 represents, power 0 represents the position of the bit. Okay. Then 4, the next bit 4. 4 is in tens position. It means the weight of 4 is 10 power 1. So here this 10 represents, it is a decimal number system, and 1 represents the position of the bit. Similarly, the next bit 6 is in hundreds position. It means the weight of the bit 6 is 10 power 2. So here 10 represents a decimal number system and 2 denotes the position of the bit. Similarly, the leftmost bit 2 is in thousands position. That means the weight of the 2 is 10 power 3. So if you multiply each digit with its weight and if you add it together, you get the corresponding decimal number. Okay. So in this example, the leftmost digit is nothing but 2. You see it has the most weight, that is the weight of 2 is 10 power 3, which is nothing but 1000. So it has the greatest weight and hence called as the most significant digit. Okay, and is called as the most significant digit, whereas the rightmost digit is 7. So if you see the weight of the 7, it is only 10 power 0. So it has the least weight and hence it is called as the least significant digit or LSD. Next, let us move on to the binary number system. So the binary number systems are used in modern computer systems, digital circuits, in order to perform logical operations, to process information, to store the information and do calculations. The binary numbers are used. So the binary number system consists of only two digits, that is zeros and 1. 0 and 1. So here these are the examples of the binary number system. 101, 11011, anything like that, but it should include only zeros and ones. Since it has only two digits, it has a base value of 2 and also called as the binary digits. By represents 2, no? So that is called as a binary digits. In short, you can say it as bits. So the weight of the each digit in a binary number system is expressed as the power of 2. Why power of 2? Because it is a binary number system. It has only two digits. So it is expressed as a power of 2. So let us consider the binary number as an example, 10101.01. It is a floating point number. It has two parts, integer part and the fractional part. So its decimal equivalent can be obtained by multiplying the weight of each bit with that bit to obtain the decimal equivalent. So for the integer part, the weights are considered. That is, here this has the weight of 2 power 0. So 1 into 2 power 0. And then this 0 has the weight of 2 power 1, the next bit. So 0 into 2 power 1. And the next bit is third position. That is 2 power 2. So 1 into 2 power 2. Then the next bit is 0. So 0 into 2 power 3. Then the next bit is, that is the most significant bit is 1. So 1 into 2 power 4. And similarly for fractional part, this is 0. So 0 into 2 power minus 1. And this 1, for this 1 into 2 power minus 2. So if you multiply the weight of each bit with the bit itself, and if you add together, you get the decimal equivalent. So this is about the binary number system. Then the next one is the octal number system. Octal number systems are used in modern computing systems, aviation systems, etc. So why it is called as octal number system? Because it uses 8 digits. It is starting from 0 to 7. It uses 8 digits and it's called octal number system. Since there are 8 digits, it has a base value of 8. Okay, it has a base value of 8. So here are some examples of octal number system. So octal number systems will not include the numbers 8 and 9. Okay, instead the next digit after 7 will be 10, 11, 12 and so on. 8 and 9 will not be considered for octal number system. So here the weight of each digit is expressed as a power of 8. Since it is octal number system, the weight is expressed as the power of 8. So now let us consider the example of an octal number. Okay, this is an octal number. So its decimal equivalent can be obtained in the same way as we seen before. That is, we have to multiply the each bit with its weight, and if you add all the thing, you will get the decimal equivalent. So the advantage of this octal number system has an advantage. It is the decimal number system. When you see the decimal number system, it has 10 digits, whereas when you go for the hexadecimal number system, it has 16 characters. Whereas this octal number system consists of only 8 digits. So it has, since it has lesser digits, the error is few or very less when compared to a decimal number system and hexadecimal number system. So the next one is the hexadecimal number system. Hexadecimal number systems are used extensively in microprocessors and computer programming. Hexadecimal number system uses 16 characters. Among the 16 characters, 10 are the numeric characters, 0 to 9 numeric characters, and the 6 are alphabetic characters from A to F followed by 9. Since there are 16 characters, the base value of a hexadecimal number system is 16, hence called base 16 system. And similarly, the weight of this hexadecimal number system is expressed as the power of 16. Okay. Now let us consider an example of hexadecimal number system. That is, this is an example 3FD.84. It is a hexadecimal number system. So the decimal equivalent of the hexadecimal number can be obtained in the same way as we seen above. That is, the weight of each digit are multiplied with a particular digit and are added together to get the equivalent decimal number. So then the next, there's a relation between the binary number, decimal number, octal number, and hexadecimal number, right? So that is the equivalence. For example, decimal number 2, the equivalent of this decimal number 2 is 0010, right? And the equivalent octal number is 2. Hexadecimal number is 2. There is no change in octal number and hexadecimal number. If you look at the 8 decimal number, the equivalent binary number is 1000, whereas the equivalent octal number is 10, right? The equivalent octal number is 10. It is because octal number, the octal number system, it consists of only 0 to 7. After 7, there will not be 8 or 9. 7 will be followed by 10. Whereas hexadecimal number system, the equivalent number is 8. Okay. And if you see the 15 or 14, so let us see the 15. So 15, the binary equivalent is 1111. Its octal number is 17. Its equivalent hexadecimal number is F. Okay. So this is the relation between the 4 number systems. That is the decimal number system, binary number system, octal number system, and hexadecimal number system. Okay. So while discussing about the number system, we have seen the base of the number system. For example, base 2, base 8, base 16. So like that we have discussed. So that is also called as a radix or base. So what is radix or base of a number system? Very simple. So as is seen, each number system has certain characters or certain independent digits. For example, the decimal number system has 0 to 9, 10 independent digits are there. Okay, so we call it as a base 10 system. Similarly, for binary number system, it has 2 independent digits, that is zeros and 1, and so it is called as the base 2 system. So thus, the base or radix is nothing but the total number of independent digits or characters used in the number system. Okay. So here given the table, that is the radix or base, and here the independent digits or set of characters for that base, and corresponding number system, how they are called. So if 2, in the sense it has 2 independent characters, zeros and 1, it is called as the binary number system. If the radix or base is 3, then it will have 3 independent characters, that is 0, 1, 2. And similarly, if the base is 4, it has 4 independent characters, that is 0, 1, 2, 3. If the base is 8, it will have 8 independent digits or a set of characters. Starting from 0 to 7, it is called octal number system. And similarly, if the base is 16, then it has 16 characters starting from 0 to 9, and then A, B, C, D, E, F. 16 characters, hence called as hexadecimal number system.